Welcome back. Let's learn how to solve equations of the form ax equals b. Alright, so last time we learned how to solve the first of the most common or basic algebra equations, that being the form of x plus a equals b, or a variable plus a constant equal to another constant. We now know how to solve an equation of this form, and so today we're going to look at the next form of an equation that you want to know how to solve, which is an equation in this form, ax equals b, or a constant times a variable equal to another constant. Alright, so in both of these forms, we are representing our variable with x and our constants with a and b. And if you remember, when we solved equations of this form, x plus a equals b, we took advantage of a property of equations known as the addition property of equations, and what you're going to see in this video is something very similar. In order to solve this form of an equation, we first need to learn another property of equations. And so let me demonstrate it for you. Let's say we have an equation of x equals 4. The solution to this equation is clearly 4. When x equals 4, the equation would be true, because if you replaced x with 4, you would have 4 equal to 4, which is a true statement. But notice that if we were to multiply both sides of the equation by the same number, let's say 2, the equation will still be true, and it will still have the same solution of x equals 4. And so let me demonstrate that here. We're going to multiply both sides of the equation by 2, so we'll have 2 times x, and that's going to be equal to 2 times 4. Alright, so we multiplied both sides by 2, and so simplifying, on this side we will just have 2 times x. That doesn't get any simpler, so we just have 2x, and then on the other side we have 2 times 4, which we know is 8. So now after multiplying both sides of the equation by 2, our equation looks a little bit different, but it's still going to have the same solution. If x equals 4, the equation will still be true. And so if we test that here, if I plug 4 in for x, let's see what happens. We're going to have 2 times 4 is equal to 8, and 2 times 4 is equal to 8. So we get 8 equals 8, which is a true statement. That checks out. So even though we multiplied both sides of the equation, which was originally x equals 4, even though we multiplied it by 2 on both sides, the equation kept the same solution of x equals 4. And this is going to be true for any number that you multiply both sides of an equation by. Just for one more example, let's say that instead of multiplying both sides by positive 2, we multiply by negative 2, just so that you can see that we can still multiply both sides by a negative number, and the solution of the equation will not change. We're once again going to start with x equals 4, but now we're going to multiply both sides by negative 2. So we have negative 2 times x, and that will be equal to negative 2 times 4. All right, once again, multiplying both sides by that number. This time it's negative 2, and simplifying, we'll get negative 2x is equal to negative 2 times 4, and negative 2 times 4 is negative 8. So we have negative 2x is equal to negative 8. Our equation now looks a little bit different, but it will still have the same solution. When x equals 4, the equation will still be true. And so let's check that. If we plug 4 in for x, we will get negative 2 times 4 is equal to negative 8, and negative 2 times 4 is negative 8. So we get negative 8 equals negative 8. And so both sides of the equation are the same number, which means that it is a true statement. And so the solution to the equation was still x equals 4, even after we multiplied both sides by negative 2. So clearly, it doesn't matter if you multiply both sides of the equation by a positive or negative number, you will not change the solution to the equation. The solution remains the same. And so what I've just demonstrated here is known as the multiplication property of equations. As I mentioned earlier, last time we learned about the addition property of equations, which lets us add or subtract the same number from both sides of an equation. Well, the multiplication property of equations says that each side of an equation can be multiplied by the same non-zero number without changing the solution of the equation. And really, this also applies to division, since division is essentially defined to be in terms of multiplication. And you'll see what I mean by that in an example in just a little bit. But really what this property boils down to is that you can multiply or divide both sides of an equation by the same number and not change the solution of the equation. Okay? The one exception to that being 0, As you see, it says non-zero numbers, and that's because multiplying both sides of an equation by 0 doesn't do anything for you because then everything is 0, and we also can't divide by 0, and so you wouldn't want to do that either. Alright, but any other number you can multiply or divide both sides of an equation by. And this is a very important property because it's going to help us solve equations of the form ax equals b, or when we have a constant times a variable equal to another constant. This property will help us isolate that variable of x, or in other words, solve for it. Let's take a look. This first example should look familiar to you because it's the equation that we got earlier when we multiplied both sides of x equals 4 by 2. We got 2x equals 8, so we already know that the solution to this equation is 4, but now I'm going to show you how you would actually find that if you didn't already know what the solution is. Now, of course, you could think about this logically. You could look at this equation of 2x equals 8 and say, well, what times 2 equals 8? It's 4, so x must be equal to 4. But as you get further into algebra and other math courses, it's not always going to be that simple. Equations are going to get much more complicated, and so you want to practice actually going through the steps of solving for a variable. Okay, and so that's what we're going to do here. Remember that the goal of solving an equation is to get it in that form of a variable equal to a constant. I like to call this isolating the variable. You get the variable by itself. And so until you've done that, the equation is not solved. All right? And so using the multiplication property of equations, we can get this equation in that form of a variable equal to a constant. That will be its solution. Specifically, what we're going to do is multiply both sides by the reciprocal of the coefficient of the variable. Or in other words, we're going to divide both sides by the coefficient. Now let me explain that. If you remember back to earlier in algebra, we learned about the parts of a variable term. This right here, 2x, is a variable term, specifically one that has a coefficient of 2, that constant in front of the variable. Okay, 2 is the constant and x is the variable. We want to identify that constant in front of the variable, and in order to solve for that variable, we will divide both sides by that constant, okay? Or what I have written here is that another way that you could view it is multiplying both sides by the reciprocal of the coefficient of the variable, okay? And so remember back to fractions, that a reciprocal is just flipping the top and the bottom of the fraction. In this case, 2. You could think of 2 as being a fraction of 2 divided by 1, because 2 divided by 1 is 2. And so the reciprocal of 2 divided by 1 would be 1/2, or 1 divided by 2. You would flip the numerator and denominator, or the top and bottom of the fraction. Okay, so if we do that here, if we multiply both sides of the equation by 1/2, here's what that will look like. We'll have 1/2 times 2x, and that will be equal to 1/2 times 8. All right, we multiplied this side of the equation of 2x by 1/2, and we multiplied this side, which is just 8, by 1/2 as well. We have to multiply both sides of the equation by the same value. And now watch what happens. If we simplify, 1/2 times 2 is 1, right? You can multiply that 2 into the numerator of the fraction. 2 times 1 is 2, so you would have 2 divided by 2, which is 1. So you get 1 multiplied by x, and that would be equal to 1/2 times 8. If you multiply 8 into the numerator there, 8 times 1 is 8, so we have 8 divided by 2, and then one more step here. Anything times 1 is just itself, so we would say that 1 times x is just x. Really, this would just be a variable term with a variable part of x and a coefficient of 1, but remember, we don't really write the coefficient when it's 1, so we would just have x is equal to 8 divided by 2, which is 4. And so now we have found the solution to this equation. We knew it was x equals 4, but now we've actually seen where it comes from, or how we would solve for it using the properties of equations. Okay, and if we didn't know if it was a solution, if we wanted to check our work, we could plug what we found for x back into the equation. So if we replace x here with 4, I'll write the check work down here, we'd have 2 times 4 equals 8, and 2 times 4 is 8, so we get 8 equals 8. And so that is a true statement. So x equals 4 is in fact the solution to this equation. All right, but back to the process that we used here, I just want to point out that you could think of this process as either multiplication or division. Technically, we multiplied both sides of the equation by 1/2, but you could also think of what we did here as dividing both sides of the equation by 2. 2x divided by 2 would just give you x, and 8 divided by 2 would just give you 4. Multiplying by 1/2 is the same as dividing by 2, and so however you want to think about it is fine. If you want to think about solving these equations as multiplying both sides by the reciprocal of the coefficient of the variable, feel free to do that, but you could also think of it as just dividing both sides by that coefficient. All right, and so that's the process. That's how we can solve equations of this form where we have a constant times a variable equal to another constant. And so to close out this lesson, let's take a look at a couple more examples where we can practice solving equations of this form. Hey there, real quick, before we get to the next part of this lesson, if you find my tutorial videos here at JK Math to be helpful, then I'd like to invite you to join my membership site, JK Math Plus, where you get access to many perks, including bonus content and my exclusive community. The bonus content includes dark mode versions of my videos, extra example problems, and more, while the community is a private space online where you can post questions, have discussions, and study together with me and other members. To learn how to join and see a full list of everything you get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. So if you are interested in becoming a member, feel free to check that out. It's a great way to support me and the tutorials I make, as well as a great way for you to learn math better. But for now, let's get back to the lesson. For this example, we want to solve the equation and check the solution, and our equation is -3y equals 15. Okay, so this equation is clearly in the form of ax equals b, or a constant times a variable equal to another constant. In this case, our variable is not x, it is y, but that's fine. It doesn't change how we go about solving the equation. We will still use the same process we used before. What we want to do is identify the constant being multiplied by the variable, in this case, -3, and divide both sides by that number. All right, so in this case, we want to divide both sides of the equation by -3, and that will allow us to solve for y. So if we do that here, and something that I like to do early on when learning to solve equations is draw a divider right below the equal sign, just to help you visualize the two sides of the equation. If you don't like the divider, you don't have to draw it, or later down the line, you can always ditch it when you're more comfortable with solving equations. But when you're first getting started, I find that line to be helpful. But we're going to divide both sides by -3. And so doing that will give us 1 times y on one side, because -3 divided by -3 is 1, so you'll just have 1 multiplied by y. And then over here, 15 divided by -3, that's equal to -5. So we get -5 on the other side, so our final result here is that y equals -5. That is the solution that we found. But now let's check it. Let's check to see if y equals -5 really is the solution to this equation. Let's plug -5 in for y and see if we get a true statement. So we're going to check our work and have -3 times y, which we are now saying is -5, and that should be equal to 15. And so now 3 times 5 is 15, but take those signs into account. A negative number times a negative number will produce a positive number, and so -3 times -5 is positive 15. We get 15 equals 15, which checks out. That is true, and so y equals -5 is the solution to this equation. Let's take a look at another example. Next up, we once again want to solve the equation and check the solution. This time our equation is 3/4 times z is equal to -9. Okay, so once again, this equation is in the form of a constant times a variable equal to another constant. This time our variable is z, and its coefficient is 3/4. And so what we want to do to solve for that variable of z is divide both sides of the equation by that fraction of 3/4. And so that's what we will do here. I'm going to draw a divider to help us visualize the two sides of the equation, but we're going to divide both sides by 3/4. But how are we actually going to do that calculation? How are we going to do the math on dividing by a fraction? Well, if you remember, dividing by a fraction is actually the same thing as multiplying by the reciprocal of that fraction. Just like from earlier in this lesson, when we saw that multiplying by 1/2 was the same as dividing by 2, the same idea applies here. Dividing both sides of the equation by 3/4 would be the same as multiplying both sides of the equation by the reciprocal of that fraction. Flip the numerator and denominator, and you get 4/3. So what we're really going to do here is multiply 4/3 by both sides of the equation. So we'll have 4/3 times 3/4 z on one side, and then on the other side, we'll have 4/3 times -9. Okay, and then simplifying, really back here we could have said that 3/4 divided by itself is 1, but we'll still find a coefficient of 1 for z here anyway, because 4 times 3 is 12, 3 times 4 is 12, so you would have 12 divided by 12, which is 1. So we get 1 times z on one side, and then on the other side, -9 times 4 is -36. So we have -36 divided by 3, which leads us to our final statement of z equals -12, right? 1 times z is just z, and then -36 divided by 3 is -12, because 36 divided by 3 is 12, but because it's -36, the result needs to be negative. And so that's the solution to this equation that we found here, but let's actually see if it is the solution. Let's check it. What we want to do is plug that value for z that we found back into the equation. So we'll have 3/4 times z, but where z is -12. And we should get -9 if -12 is a solution. Okay, so we'll have 3/4 times -12, and that will be equal to -9, or at least we're hoping it will be. If you multiply -12 into the numerator of this fraction, -12 times 3 is -36. We just sort of talked about that down here, but we'll have -36 divided by 4, and that will be equal to -9. And then -36 divided by 4 is -9, right? 36 divided by 4 is 9, but because we have -36, the result will also be negative. So we have -9 equals -9, and so the equation is true, meaning that -12 is the solution to this equation. Okay, so the bottom line here, something that you might want to make a note of, is that when the coefficient of the variable is a fraction, instead of dividing both sides of the equation by that fraction, just immediately go to that step of multiplying by its reciprocal. That's ultimately going to be easier when you want to go about solving the equation. So if you have a fraction, multiply both sides by its reciprocal. If you don't have a fraction, or just a whole number, or even a decimal number, then what you want to do is divide both sides by that number to make your work as simple as possible. Okay, but enough about that. Let's take a look at one more example for this video. For our last example, we once again want to solve the equation and check the solution, but our equation looks a little bit different than what we've worked with so far. We have 5x minus 9x equals 12. And so this doesn't seem to be an equation in the form of ax equals b, or a constant times a variable equal to another constant. But something that you might notice here is that these two terms are like terms, right? 5x and -9x are two terms with the same variable part of x. So what we can do is actually simplify this equation first, and then it will be in a form that we recognize how to solve. Okay, sometimes you will get equations that are not fully simplified. You will have to do a little bit of work or combine like terms before you are actually able to isolate and solve for the variable. Okay, because right now in this form, we have two different instances of x, so it's going to be difficult to isolate x unless we combine those terms so that we only have one x and can solve for it. Okay, so let's do that here. Let's combine these two terms. Remember that when you have like terms, to combine them, you just add their coefficients. 5 plus -9 is -4. So what we get here is -4x equals 12. All right, those two terms, I'll just make a note of that here, were like terms. Okay, but now our equation is in that form of ax equals b, a constant times a variable equal to another constant. And so now we can do what we've done in the previous examples, identify the coefficient of the variable. In this case, it's a -4, so we can divide both sides of the equation by -4 to solve for x. Okay, so let's do that here. I'll draw a little divider. If you divide both sides by -4, -4 divided by itself is 1, so we get 1 times x on this side of the equation. And then over here, 12 divided by -4 is -3. So we get x is equal to -3 because x times 1 is x. So that's the solution that we found here. We found that x equals -3 is a solution to this equation, but we should check it to make sure that it is the right answer. However, which form of the equation do we use to check the solution? Well, really you could pick either of them. Assuming that you combined your like terms correctly, you can plug that value of x into either of them to check the solution. Okay, so if you're not sure if you added your like terms together correctly, your best bet is to just plug the value of x you found into the original equation, no matter what it looks like. So in our case, if we were to check our work here, we would have 5 multiplied by x, which we're saying is -3. So we have 5 times -3, and then we were subtracting 9 multiplied by x, which once again, we're saying is -3. And that should be equal to 12. So let's check it. 5 times -3 is -15, so we get -15, and then we are subtracting 9 times -3, which would be -27, so we're subtracting -27, that's equal to 12, and then those two negatives would cancel out, so really you would have -15 plus 27, so we have -15 plus 27 equals 12, and -15 plus 27 would be equal to 12. So this equation is true. We get 12 equals 12, which checks out, and so -3 is the solution to this equation. Okay, and so that is it for this example, and this was also the last example for this video, but if you do want to get some more practice solving equations of this form, feel free to check out the examples video for this topic that I'll have linked here on the screen. If you have any questions, please let me know in the comments, but if you don't have any questions, this is all I had for now, so I will see you next time.